physics review. Thought I could do it in one video. It looks like it's going to have to be 2 videos. Sorry about that one, but still it's not going to be too bad. Some of this is review, some of it we barely touched on, some of it is kind of tangent of what we've touched on. So let's look at it. We just have one more that I'll do over the weekend for you. The first standard here is 7P2, the overarching one. It says, understand the forms of energy, energy transfer and transformation, and the conservation in mechanical systems. So the first one, the blue here, is says 7P.2.1, kinetic energy, potential energy, and mechanical energy. We've talked about those. Again, you can go back to some videos, previous videos, energy part 1, 2, and 3. Remember, part 2 and 3 were actually cartoon clips that I had pulled that you could look at. But I want to make sure that this is explicit. It says an object that possesses mechanical energy is able to do work. When we think about the concept of work, I want you to remember that something always has to move. Remember, I think what I told you was if you pushed against a wall, if you pushed against something and nothing ever moved, you did no work. I just did more work than pushing on a wall that never moves. Alright? Mechanical energy is the form of energy involved in the operation of simple machines. Our last video will be a little bit more detail about simple machines, and there is one very short video clip about simple machines that you can look for on my website too. The next one, which really is a review, is 7P.2.2, which is the transfer of energy from potential to kinetic. Again, that's energy part 1. You can look that one up. This one I really wanted to talk about some more to make sure that we have really covered it. And the standard says to recognize that energy can be transferred from one system to another when 2 objects push or pull on each other over a distance. Pushing and pulling over a distance is actually the definition of work again. And electrical circuits require a complete loop through which an electrical current can pass. So here I drew a picture of an iPad or a tablet or any device you've plugged in. Plug it into the wall. You know what happens if you have a short in the wire, you cut the wire or you unplug the wire, your device dies. It doesn't charge up. To have the electrical energy actually work, the current must have a complete loop to pass through. When you cut that, it doesn't work. That's probably the most basic form I can think of. And I know you all get that because you all charge something from one time to another. Now, energy transfers from one system to another 4 different ways. One is thermally, when you have a warm object and a cool object. Here I have a little teeny ice cube I drew and it's melting. If you put that ice cube, like when my husband was defrosting the freezer the other day, he put it on the concrete out in the driveway and it melted because you had the heat and the cool and you had a transfer of energy. To mechanically transfer the energy, you have to push or pull something over a distance. Here I've just got a box we push or pull. Again, that push or pull over a distance is work. To electrically transfer it, when you plug in that device to a battery or to an outlet, that's actually transferring energy. And then the last one is electromagnetic waves. It's caused by the vibration of an electric charge. You've seen maybe an explosion or something and you see the waves that go out. That's that concept. Now it's important, when energy transfers from one system to another, heat is always involved. Heat is always involved. When energy transfers, heat's involved. If you've ever plugged in a laptop and you know that little brick that's in the plug, when you touch it, it's hot. Did you ever notice that? Think about it. That's because energy is being transferred. Now, batteries store and transfer energy. You know that, you might not think about it. Electricity is important because we use it for so many things. Here I have a light bulb. If I didn't have a light bulb, it's dark outside. You wouldn't be able to see what was going on. If my flip camera didn't have batteries, it wouldn't run. You've got to transfer the energy. To produce electricity, a heat source is always required. Now, you know if you have a light bulb and you want to change it and you touch it right when it's plugged in, it's hot. Think about that. You know those things practically, you probably don't think about them scientifically. Now, the burning of fossil fuels is one way that we produce electricity. Water power, if you think about the Catawba River, there are dams all up and down it. Those are typically hydroelectric dams. And we have wind power. And around here we don't have a lot of wind farms. But Google them. They have gigantic windmills that harvest the wind energy. It's pretty cool. Now, fossil fuels, water power, wind power, not all are bad, but definitely fossil fuels, those are really something that produce a lot of pollutants, and you hear about them in the news a lot. You hear about global warming and things like that. But we do have natural forms of an electrical energy. Lightning, that goes back to the weather unit. Solar energy goes back to the weather unit. Water power, like the hydroelectric dams. Wind power, all of this really goes back to our weather unit at the beginning of the year. Do you see how it all ties together? These forms of energy, for electrical energy, are green energy. They don't produce extra pollutants. Fossil fuels have pollutants to them. They can cause other issues. When we talk about good stewardship of our earth and good health of humans, if we can have green energy, it would just be healthier for all of us. Now, that's almost all of our review. Like I said, one more to go. We're going to get through this. You're doing a great job. Look over the weekend and I will put up that last video by noon on Saturday at the latest. And we will have a little bit of time after our social studies test on Monday. We're going to get it done. You're doing a great job.